Hey everybody, it's Mr. Rivetto from the math department. Just want to start talking to you guys about a review of rational expressions. Now, these are something that they're going to come up a lot this year. In the past, everyone's had this overwhelming fear of fractions for some reason, and there's really no need to. Hopefully this year we're going to be able to solidify that. Let's just kind of quickly go over a few things. A rational expression, what is it? Think about a ratio, first of all. If you think about it, rational has the word ratio in it. A ratio, if you learn in Algebra 1, it's just a fraction. So a rational expression is the quotient of two polynomial expressions, okay? So an example of that would be something like x plus 1 over x, pretty much any polynomial over another polynomial. And remember, monomials are still polynomials. This year, it's going to be super important. We want something to be in simplest form. Simplest form is when there's no common factors in the numerator or the denominator anymore. So basically, it's very easy to get to simplest form. You're just going to factor the numerator and denominator. Now you factor them separately, independent of each other. You know what you factor up top doesn't make a difference on what you factor in the bottom, and vice versa. Okay, and then you cancel out all the remaining factors. I like to think of that if you think about it, what does anything divide by itself? Well, it's just 1. So this term cancel out, it doesn't really mean just they disappear. What actually is happening is they're reducing to 1, okay? Not entirely something important, but it's something when you do want to think about moving forward in your mathematical careers if you choose to pursue something in math. Now, what is a common factor? That's just any term that's exactly the same in the numerator and the denominator, okay? So a couple things, keep those in mind as we move forward. Let's do a few practice problems together. Now, like we talked about, our first step is to factor the numerator and factor the denominator. So the top in question 1 is a trinomial. What adds to 4 and multiplies to 4? So that's going to be x plus 2 and x plus 2. Okay. The denominator here, what adds to 3 and multiplies to 2? Well, that's going to be x plus 1, x plus 2. What cancels out now? Okay, I've got an x plus 2 here, an x plus 2 here. And then what's going to be left? Well, very simply, all that's left is exactly what's not crossed out, x plus 2 over x plus 1. Okay, so this is your answer right here. That's all there is to it. Like I said, for some reason, we've got this overwhelming fear of fractions when it's just 2 factoring problems in 1. There's really nothing different there with these rational expressions as everyone thinks. But let's keep practicing for now. Question 2, again, I want to factor x squared minus 6x over 6 minus x. While I look in that numerator, it is not factored completely. So if I factor that completely, I'm going to pull out a GCF of x. I'm left with x minus 6. In the bottom, I'm left with 6 minus x, because that is factored completely. Now, this right here is that one special case where if you read, it says a common factor is any term that is exactly the same. Well, I don't have anything that is exactly the same. However, what we could do, there is that special note, okay, that a minus b is the same as negative b minus a. And we can always check this. Sorry, let's get this, you can read that a little bit. We can always check this by by multiplying out if I need. If I wasn't sure, I'd have negative b plus a, which I could just rearrange that order, a minus b. These two things are the same. So why did I bring that up? Well, this is that one special case in math where I can actually cross these out. However, I must replace one of them with a negative 1. Now, if I replace that with a negative 1, what's left up top? Negative 1 times x is going to give me negative x over 1, which is just negative x. So keep in mind, That's that one special case that I hope everyone pays attention to and looks for, is when, if you look, I had x right, I had x in the front of my numerator term, but it's in the back of my denominator. The 6 was in the back and then it's in the front, and that's not necessarily what makes it that special -1 case. It's that the x was positive and it's negative, the 6 was positive and then it was negative. So just make sure you're paying attention to that spot there. Let's keep going. Question 3. Again, this question here is one of those, it's 2 terms in the numerator. They're not perfect squares, but they are perfect cubes. So what do we want to do here? Well, in order to factor something like this is going to use that SOAP factoring stuff, where I'm going to first set up a binomial and then a trinomial. What is the cube root of x cubed? It's x. What is the cube root of 8? It's 2. What is x squared? Well, very simply, it's x squared. If I multiply the x and the 2 together, I get 2x. And what is 2 squared? It's 4. Now this is where SOAP comes into play. Okay. So those signs there are going to be, what did I start with? That's a negative. Same sign. What's the opposite of a negative? Plus. AP stands for always positive. So I have a plus there. Okay. I am going to get rid of these here. You know what I'll do for you though? I will put it SOAP. That way everyone still has it. If you need, take a look at SOAP factoring again. I believe that's in our first lesson, so please take a look there. How does the bottom factor? Well, that one's going to factor by GCF. If I pull out an x squared, I'll be left with x minus 2. Do I have anything that is exactly the same? I do. X minus 2, x minus 2. And then what's left? Well, the trinomial from my SOAP factoring over this x squared. Now, how did I know that I couldn't factor that trinomial anymore? Well, there's no factors of 4 that add to 2. Okay, so you can remember that. But if you do remember SOAP factoring, that trinomial is never going to factor for you. So don't necessarily worry about that. Can I cross out the x squareds? No. Okay, those are not exactly the same. One is an x squared term that's part of a trinomial, and the other is x squared itself. That's it. So I can't cross that out. They must be exactly the same. Okay. Moving forward to question 4, that numerator is going to have a GCF of x squared. So if I pull out x squared, I'm left with 3 plus x squared here. On the bottom, there's nothing that I can really do there. I'm just going to leave that as 2x. Now, there's nothing that's exactly the same here. But what I can do is I can get rid of this x squared symbol with this x here. And then the last thing that I'm left with, I still have 1x. I still have this 3 plus x squared. Mr. Rivetto, should we rearrange the order? You can, but you don't have to. You know, to me, that's just an extra spot that you could potentially make a mistake rearranging it. Just leave it. No one cares that it's 3 plus x squared instead of x squared plus 3. So just leave it. And the bottom is a 2. So that's it. That's those problems here. I never boxed off this answer. So let me go back to that. And then we've got this one here. So that's everything from these first 4 examples. Now moving forward, we are going to look to add and subtract rationals. Also, we want to make sure that we're going over those steps too. This one has a little bit more in depth to it. I want to find a common denominator. Now, realistically, any common denominator works. However, it's the LCD that makes it the most efficient and the easiest for you. Okay, so we want to look for that LCD. I multiply each numerator and denominator by the missing factor of that LCD. So if one term is missing something, I have to multiply both top and bottom. And then I combine all the terms in the numerator distribute the sign if it's a negative. So subtraction is the same steps as addition with that one extra step of distributing the negative. And then from there, we're kind of done. Remember, you don't physically touch the denominators when you're finally adding. You only add the numerators. So let's see here. First thing I'm going to do, I don't like how this looks. I'm going to put this as x over 1 plus 1 over x. So now that I have x over 1 plus 1 over x, I want to look between 1 and x, what is my LCD? Okay, well, that LCD, I'm going to multiply the top. You know what, let's use a different color. I'm going to multiply this term by x over x. This, the right fraction already has a denominator of x, so I leave it. What that's going to do for me is that's going to give me x squared over x plus 1 over x. I now have the same denominator, and now that I have the same denominator, I get x squared plus 1 over x, okay? So it's important, that's just your answer. There's nothing left to do with it, okay? There are no common factors. X squared plus 1 does not factor anymore. Cannot simplify, because if I simplified, I would be right back where I started. Yeah, so that's it for this one. Okay, I'm just gonna get x squared plus 1. Okay, now down here for question 2, this one, this one might require a little bit more. If I look here, I've got 1 over x plus 1 minus 2 over 2x minus 1. Now, what I'm going to do in this problem is, first of all, I'm going to rewrite it. And when I rewrite these, I want to make sure I'm giving myself some space. So I'm going to put my minus 2 over 2x minus 1. You know what? I'm going to throw these in parentheses. Reason being, what's missing between x plus 1 and 2x minus 1 on the left side? Well, I need to multiply top and bottom by 2x minus 1, 2x minus 1. Okay, what's missing in this one? I need to multiply both by x plus 1, x plus 1. Okay, so from there, let's see what we can do. 2x minus 1 times 1 is going to be 2x minus 1. This denominator is going to be 2x minus 1, x plus 1. I'm going to keep this minus sign. If I were to multiply this out, I'm going to have 2x plus 2 over 2x minus 1, x plus 1. So now I look, are my denominators exactly the same? They are. Okay, so now that they're exactly the same, what I can do here is I'm going to rewrite this as 2x minus 1 in parentheses minus parentheses 2x plus 2. And that's important because this is exactly what I was talking about a few minutes ago, where you have to remember to distribute this negative. So you don't ever want to jump the gun there. But then my denominator is 2x minus 1 over x plus 1. I'm going to scroll up a little bit, give us a little bit more room. This is now going to be 2x minus 1 minus 2x minus 2 all over 2x minus 1, x plus 1. Now I'm not allowed to just cross things out. Like, why couldn't I cross out the 2x minus 1 and the 2x minus 1 in this step? Because again, if I were to cross something out there, it would just put me back where I started, and that kind of defeats the purpose. So we want to make sure we're not doing something like that. Now, what can I do from here, though? If you look, I've got a positive 2x and a negative 2x. Those terms cancel out. So what does that leave me with? Well, that leaves me with negative 3 over 2x minus 1, x plus 1. And that's my answer. Okay. I think we've got another practice problem here. So let's move along with that one. Now, this problem, again, I might have some trouble with it at the beginning if I just try to look at this as x and x squared minus 1 and then 3 over x plus 1. The issue is going to be that those denominators are not fully factored. So I'm going to actually start this problem by factoring this denominator. And we all know that x squared minus 1 factors to x plus 1, x minus 1. And now by doing this, let's see what I did. I can now clearly see that the LCD is x plus 1, x minus 1. And because of that, I don't need to multiply the left fraction by anything. I only need to multiply the right fraction by x minus 1, x minus 1. And when I do that, the left fraction does not change. The right fraction becomes 3 times x minus 1 over x plus 1, x minus 1, which I'm just going to do, I'll rewrite one more time, x plus 1, x minus 1 plus, that's going to give me 3x minus 3 over x plus 1, x minus 1. So basically all I did, everyone, was I just distributed this right here. Okay. Now from there, are those denominators exactly the same? They sure are. So since those denominators are the same, what we have here is going to be 4x minus 3 over x plus 1, x minus 1. Can I simplify? That numerator does not factor. So that's it. I'm done. Nothing left to do in that problem. Okay. We've got one more to try here. Now, again, that denominator looks a little bit on the stranger side. What is it that I could do with this problem? Well, if you look, I can actually factor that left fraction a little bit more, and that might make my life a little bit easier. I'm going to have 1 over 2. I'm going to pull out an x. And if I pull out an x, I'm left with x plus 2 minus 1 over 4x. And now that should help me see a little bit more as to what do I need to multiply here by. The left fraction is very simply just missing a factor of 2. Okay, so I'm going to multiply this one by 2 over 2. Okay, the right fraction is missing. It has the x. It has this x. It has that 4 already. So what do I still need to multiply by? I'm going to multiply. Oops, that's the wrong thing there. Sorry. I'm going to multiply this one by x plus 2. X plus 2. Okay. So what does that do for me? The left fraction turns into 2 over 4x, x plus 2. The right turns into 1 time, that's going to be x plus 2 over 4x, x plus 2. Are those denominators the same now? They sure are. So what we're going to do is we're going to do that extra step that we talked about. We're going to distribute here. Since the denominators are the same, I'm going to combine those. This is going to be 2 minus x minus 2. What does that do for me? Well, similar to before, I've got a 2 here, a negative 2 here. Those go away. I have just a negative x up top over 4x, x plus 2. And then what can I do from there? This x can go away with this x. And my final answer is going to be negative 1 over 4 x plus 2. Okay. So that's how we add and subtract rational expressions. Hopefully that makes sense and that comes back to you. Rewatch this video a few times if you need to make sure that makes sense. But now let's just talk about complex fractions. These ones, they hold something similar, except now you're just multiplying numerators by the LCD, not both the numerator and denominator. Or if you want, you could just keep change flip here for a second. But let's go on. Let's actually try some of these here. The first thing I'm going to do is I like to work. I need to see this a little bit bigger. So someone try to help me out here. Think to yourselves, between 2x and 4, what is my LCD? Well, that LCD is going to be 4x, and hopefully everyone can understand that. So I'm going to multiply all of the numerators only by 4x, and now let's see what's going to happen here. Okay, so if I look, this 2 and this 4 is going to go away. So what's that going to leave me with? That's going to leave me with 2x times 1 is 2x. Let's keep the plus sign. What's going to happen here in this next one? This x and this x go away. 3 times 4 is going to give me 12. And in the bottom, what's going to happen there? Well, this 4 and this 4 go away. Now I'm going to give you a hint. Don't multiply that out, because if you do, your next step is going to have to be what? Your next step is going to have to be to factor, and then you're just undoing what you just did, so don't waste the time. We're just going to write this as x plus 3. Now, there's no guarantee that it's going to help you, but it might, okay? If we go along here, let's factor that numerator. I've got a 2, x plus 6. The bottom is x plus 3. Does anything cancel out? It doesn't. So this is just my answer. I don't have anything else to do here. That's it. We're done. Nothing else for that problem. Okay, but we did just simplify that complex fraction. So now that that one is complete, let's go to our last one. And in this last problem, I think we're going to try to use this whole idea of keep, change, flip, if you will. Okay, so moving forward down here, just like before, the first thing that I'm going to do is I'm going to rewrite this problem just so that I have it a little bit better right in front of me. I've got x squared over x minus 4 plus 2 over 1 all over 2x minus 2 over x minus 1, again, over 1. Now, this is a situation that since both of these fractions kind of have a constant at the end where it's just a whole number, I actually think it's going to be easier for us to, let's multiply this by x minus 4, x minus 4. And then what's that going to do for me? Well, that's going to give me x squared over x minus 4 plus 2x minus 8 over x minus 4. We'll see what that does for us in a bit. On the bottom, what I'm going to do is I'm going to multiply this term by x over x. And again, what will that do for me? Well, that gives me 2x minus 2 over x minus x over x. Then think about what we just went over. Think about what we just went over when it came to adding or subtracting fractions. Now that I have the same denominators, what I can do is, and I'm going to come over here for everyone, I have x squared plus 2x minus 8, which I do believe that can be factored more, so we'll take care of that in a little bit, over x minus 4, all over 2x minus 2 minus x over just x. Now, what this is going to do for us, guys and girls, is I'm going to keep the top fraction, x squared plus 2x minus 8 over x minus 4. I'm going to change this division to multiplication, and I'm going to flip that bottom fraction. Now, when I do that, I'm also going to put some like terms together. So if you look here, I've got a 2x and a negative x. So that's going to simplify. So that's where this is going to come from here. But then I'm going to flip this to x over x minus 2. Now, again, where is x minus 2 coming from? 2x minus 1x is just x, okay? And then I still have that negative 2 there. From here, like I said, I can find something that adds to 2 and multiplies to negative 8. That's going to give me x plus 4, x minus 2 over x minus 4 times x over x minus 2. Do I have anything that's exactly the same? I do, those x minus 2's. Now I can't touch the x plus 4 and the x minus 4. Those are two entirely different terms. So what we have here, and our final answer is just going to be x plus 4 over x minus 4. There's nothing else that can be done. So that's just my answer. Okay. Now, like we've been talking about, these videos are more of an extra resource for you, but there's nothing better than being in class and getting to watch these videos live with us. If you have questions, make sure you're asking, because there's no way that we can help you if you don't. And yeah, we'll be back soon with the next lesson. Have a good day, everyone. Bye.